Alright guys, I'm going to try and make this as quick and painless as humanly possible for you today. Obviously I'm not in today. Me, Mr. Rose, and Mr. Ho are all downstairs right now. We have to go through your Ames web test and kind of come up with a plan on what to do next. So we're out this afternoon. We'll be back first thing tomorrow though. So if you have any questions on anything, you'll be able to stop in and see me. For today, you're going to be pretty much on here the entire time. You're going to go through, if you see the agenda, you're going to go through and you're going to do your 4 bellwork problems. I'll put the problem up, you try it, and then kind of go through with me and make sure you got those correct answers. It's exactly like the problems from your homework. I may or may not have made them a little bit harder just to make sure you got it. I'm randomly going to throw in a little story from my 8th grade year. I'll give you a little break from work and let you kick back and just listen for a minute. I'll go into notes for graphing quadratic equations. So you just did factoring, and from that factoring, you had to figure out solutions. Now you're going to graph it and find solutions. We'll do 2 or 3 practice problems together, and then I'm going to give you some time for the homework. So instead of having the sub teach it and do it, we're just going to roll this way today. Okay? So here we go. First bellwork problem, I want you on a scrap sheet of paper. Okay, so get a scrap sheet of paper out for these 4 problems. The first problem just says factor completely. 4x to the third minus 7x squared plus 4x minus 7. This is exactly like your homework. 4 terms, so go ahead and pause it real quick, give yourself a chance to do some work. Alright, I'm going to try these as well. First thing I do automatically is I go through and I want to find that they're in order. So I see x to the third, x squared, x, and then just my constant. Then I break them into 2 groups. I make sure I take the sign in that second group as well, so I have to see that plus or minus sign there. Alright, I see the first one doesn't have any numbers in common, but it at least has an x squared. So I factor out an x squared times 4x minus 7. The second one, there's really nothing in common. There's no numbers, there's no variables, nothing. So really, a 1 is the only thing it has in common. So I'll do 4x minus 7. I know I did this right if I had the same common factors inside the parentheses. So that is one of my factors, 4x minus 7. The other factor is whatever's on the outside. So I see x squared and a 1, so I know it's x squared plus 1. Okay, and that would be it. So question number 1 for your bell work, that would be it, your 2 factors. Question number 2, have you write this down on your scrap sheet of paper as well. This one I made a little bit crazier. So it's got some crazy stuff going on there. 72m n to the second w and so on. Go ahead, copy that down, then pause this and give yourself a little chance to do some work. All right, so I see in some case there really is no order. So what I'm going to do is I'm going to try just breaking it up into 2s and see if it works out. If it doesn't work out, maybe I have to change the order to try and get those common factors to be the same. So I split it up in 2. Hopefully you have a nice teacher and they put them in order so you don't have to redo this. Between 72 and 126, that is a crazy one. I know that 9 goes into it. 36 maybe. 36, 90, 120 now. I'm going to go with 9. I'm going to see if 9 is the biggest thing that goes into it. That is a crazy, stupid problem. N squared, they have that. So on the inside, that's going to be 8w minus. That would be a 1, and then 4k, right? Is that right? N squared k, that's right. All right, over here, 120 and 210. All right, I know 10 goes in. 15 maybe. 15 goes in. 30 goes into it. I'm going to try 30. So if I do 30, n to the third w, n to the third k, so I know n to the third, times 4w minus 30 times 7. So it'd be 7 in the third k. All All right, so if I look at this, this is the first time, man, I had it factored by grouping. I know I did everything right. I can see they have the same terms. They have a W and a K on the inside of my factors, but they're not the same. But if you notice, my first term is double what the term on the right is. So that tells me I could have factored out more on the left-hand side. So I'm guessing 18. I'm going to guess that I could factor out 18. 18 does go into 72. 18 does go into 126. So I'd have to go back. That's all right. If I could have factored out an 18, it's going to double everything here. That should really be 18. Now this is going to turn into my 4 and 7. So I better just I don't know if I can do this. 4 and a 7. So really it's going to be 4W minus 7K. All right, and that is the safest bet on how to do these. If you factor these and you realize, man, I did everything right, but I'm just off by a few numbers, just go through and double check, could I have factored something bigger out? Since they're the same on the inside, I know one of my factors is 4W minus 7K. On the outside, I take whatever it is, so 18mn squared plus 30n to the third. That would be it, peeps. All right, question number 3. 3 is going to be a little bit easier than that one. Okay? 3, we go down to this guy. Oh, it doesn't look easier, though. 32x squared plus 48x plus 18. We're going to factor this. That's all we're doing. So if you want to pause this, go ahead and give yourself a chance. All right, first thing I need to do is figure out, can I divide anything out of this? Can I make this any smaller? I know I can divide them all by 2. So really that's 2 times 16x squared plus 24x plus 9. One of the rules from your homework was called the perfect square trinomial. We know that if we look at the a value and we look at the c value, if they are perfect squares, I can break this up into just one binomial squared that's going to equal that. So I know I have 2. The square root of 16x squared would be 4x. The square root of 9 is 3. And then we always take the sign in front of b and bring that down, plus sign, and we just put our squared up here. So anytime it's a perfect square trinomial, it's going to turn into just one term squared. Now, just to share, you could have went through and you could have done your entire x, and you could have factored and done 16 times 9 and got that number. Then you could have put your 24 at the bottom and actually done your normal factoring. You would have gotten the same exact thing as us, other than yours would have looked like 2 times 4x plus 3 times 4x plus 3. So yours would have looked that way instead. Okay, so perfectly fine. Just know that we're just trying to show you a little shortcut for the perfect square trinomials. Bellwork question number 4. Now this one looks a whole lot easier. Look at it, I see 25v squared minus 16u squared. Go ahead and pause it and give yourself a chance to work. All right, this is a difference. I know it's a difference of 2 perfect squares looking at it right away. There's nothing I need to or can factor out. So I look right away and say, all right, that's perfect square, that's a perfect square. So the difference of 2 squares always gives me 2 binomial terms to multiply together to get that. The square root of 25v squared is 5v. So I put that as my first term on both. The square root of 16u squared is 4u. And the difference of 2 squares always gives me a plus and a minus. So that would be my factored version of what's going on there. All right. If you are done, I'd like you to pause this for a second. I want you to go up, get your notes packet from the front table or from the teacher, head back to your seats, and then as soon as you get back to your seats, go ahead and press play again. I'll tell you a little story about my 8th grade. All right, hopefully you've got your notes packet now. This kind of randomly popped into my head today as I was sitting here getting ready to do the notes. When I was in 8th grade, I had my best friend Anthony Battle. We were together all the time. We did all the sports together. We were in band together. We were in choir together. We were together before school, during school, after school, really inseparable. And I've seen some things in school that really made me think about this recently. And the things I'm talking about is just people messing up. Like you do something, you realize, man, that was dumb. I shouldn't have done that. I can't believe I did that. Uh, Teacher might be mad, parents might be mad, but just kind of a story to show you that it happens to everybody and you move on with your life, you learn from it and kind of go. All right, my story starts with my parents had my aunt and uncle over to the house. They were playing cards downstairs, and Anthony and I decided we were going to go up into the attic. And at the time, my sister lived up in the attic, one of my older sisters, Terry. Our attic was decorated from top to bottom, so floor, walls, ceiling, everything, with carpet squares. So if you picture going into a carpet store, they have all the samples. We had thousands of carpet samples that we bought, and we stapled them to wall, ceiling, everywhere. So the entire room was carpeted, floor, wall, ceiling. Just looked pretty cool. All different colors, just kind of random. So 25 years ago, that was kind of a cool thing to see. I've never seen anybody else do it before. When we got up there, we were just hanging out playing some games because we had storage on one side of it. And we saw some toilet paper, and we kind of laughed about it. We're like, hey, let's toilet paper her room. It'd be kind of funny. We were 13 at the time, 14 maybe at the time, and she was, what would it be, 32, 33 years old, something like that, so she was older. So we thought it'd be pretty funny. So we get out the toilet paper and we start hanging it from everywhere. We go from bed to dressers to storage area, completely covers the top, or the entire attic up there. After that, we start looking around. We're like, all right, now what can we do? We're done with this. Now what? And we see a lighter and we see some incense. This might be the dumbest thing I've ever done in my life. So, all right, let's just light this and see what it smells like. So we lit it and we were smelling it. I just had it sitting up there, not doing anything particularly dumb with it. But then we took one little square of toilet paper. Just took one piece off. We're like, yeah, let's just see if we can burn a hole through it. So we took the incense, the little poker thing, we burned a little hole through this. We kind of sat there like, oh, that was cool, it made a little hole. So we did it again, made another little hole. We started doing little designs in it, messing around. Thought nothing of it. So then randomly, I don't know why we did, we took the incense and we stuck it through the toilet paper that was actually connected to everything. And the very first time we did it, it took off. The entire attic within seconds was completely engulfed in flames. So Anthony and I were up there with all of my sister's belongings, all of our storage, everything, and the entire attic was on fire. We didn't know what to do. We were freaking out. We knew there was no way we were going to get it out, so we ran downstairs. I told my dad. My dad knew what we were doing. He knew we were toilet paper in the attic, so he thought we were just joking and wanted him to see it. So he just kind of laughed it off, didn't believe us, and then we kind of freaked out, and he understood it then. So he grabbed the fire extinguisher, ran upstairs. My mom called 911. So my dad was up in the attic spraying this, trying to get the fire out. And after a couple minutes of my dad being up there, he came down to the middle floor and kind of fell down on the ground from all the smoke, and then went back up for more. When he got back up there, the firefighters had already broken through the attic window and were spraying stuff down in the attic. And as you could imagine, every single thing was ruined. So every one of my sister's belongings, she was older, she was working, she had just moved back in at home. She had just got a new job in town. So she moved back, everything from clothes to personal belongings, everything ruined. Everything Anthony had up there ruined. All of our storage ruined. Just because of one stupid mistake we made. Now, were my parents mad? Yeah, my parents were irate. We could have burnt the house down. We could have died. I mean, a lot of bad things could have happened. But Anthony and I learned a lesson. We definitely learned about not playing with fire. We learned just about making good choices, doing things the right way. So that really, this is just my way of showing you guys or telling you guys, everybody, especially in middle school, maybe at the beginning of high school, you're going to make one stupid mistake. Don't think that it is the end of your life. Don't think that it's going to ruin you. Whatever it is, you can fight back, get through it, learn from it, and kind of move on with your life from there. Okay? So just kind of an interesting little thing for you to kick back and listen to there. All right, so getting into our notes now. So now we get to go into to some math after burning my house down. So for the notes, you guys are talking about graphing quadratics today. All right, if you remember, this should be the first note that you write down. I'd read it kind of small up top right where it says notes. You want to write down that quadratic equations or the solutions to quadratic equations are just where the graph crosses the x-axis. That's one key thing you have to keep in your mind, whether you're factoring, you're graphing, or you're doing our other ways that you'll see next week. If you find the solution to a quadratic equation, so if it says x squared, you know that you're finding where the graph crosses the x-axis. That's the end goal. Okay? All right, I'm going to put a whole lot of stuff on the board here, and hopefully you can kind of fit it in somewhere. The first one that I'm going to put up here, I want you to draw a little graph on the left-hand side. So just draw it maybe like this. And let's say, put a point right here. And we're going to make your graph go through here, or maybe go through here. Okay? Kind of ugly. It should be more circled than pointed like that. It should be kind of rounded off a little bit there. But it's going to go through that point. Very first thing, I want you to draw a dotted line directly through the middle of this. That dotted line that you see is what we're going to refer to as the axis of symmetry. The axis of symmetry is just a line that cuts your graph exactly in half. So one side is going to mirror the other side. That axis of symmetry is always going to be an equation x equals some number. Because you know when you graph a vertical line, the equation always starts x equals something. So axis of symmetry is always x equals something. The next point is going to be this guy right here. This is what we're going to call our vertex. When you have a vertex, that vertex is the minimum when the graph opens up. So if you look at it right now, the graph is pointed up. So that is a minimum. It's a minimum value when the graph opens up. And if the graph would go down, so if the graph would look like this, it would have a top point, so it would have a max. If graph opens down. And we know these just by looking at the equations. If it's a maximum, your a value is going to be negative. And if it's a minimum, so your graph's going up, then your a value is positive. Okay? You should have room either still on the left-hand side or maybe a little bit more in the middle. I'm going to erase some just so you can see it a little bit better. Every time you graph these, you're going to create some type of table to help you get the points on the graph. So in your table, you're always going to have your x and your y. We're always going to put the vertex right in the center of our table. So this is the vertex. So if I use our example that we have and kind of make up a point, I'm going to say maybe that's -2, -3. Okay, so we're going to say that's our vertex of our graph. That's our minimum point. To create the table, we always go, it doesn't matter which direction, but you're going to put at least 2 more points on top and bottom in order. And they're always going to mirror each other. So if I would look at like -1, maybe I just kind of pick a number and say that's really -1, -2. If I look at -3, that's really -3. So you can see they should be, if it was a good graph, there'd be equal points. If I look at 0, 0 crosses at 0, and -4 would also cross at 0. Okay, we would also see that those are the solutions when I'm looking for the x-intercept, so I'm looking for those values, so those would be my solutions as well. So it'd be -4 and 0. Okay? Now, steps for you to graph. Hopefully you can fit this on the right-hand side. If you need a little bit more space, you can get some more space on a piece of paper. Your steps to graphing. Number 1, put in standard form. So that is ax squared plus bx plus c. So just make sure you always have that x squared part up first. For your part 2, your second step, that is find the, I'm going to say AOS because I'm out of room, that's axis of symmetry. The equation for your axis of symmetry is x equals negative b over 2a. You have to know what your a, your b, and your c are in order to do this stuff. Okay? When it says negative b, so this right here, it's really just saying the opposite of b. So your equation is x equals the opposite of b over 2a. Step 3, plug in your AOS or your x value to find the y for vertex. You picture if x your axis of symmetry, the y value that you find is going to find like the second value, so you can plot that point for your ordered pair for the vertex. And for step number 4, create table and graph. Okay, so we put it in standard form, we find the axis of symmetry, we plug in x to figure out what our y would be, so we have a vertex, and then from there we create a table and a graph. Alrighty, let's give it a shot. I'm going to do 3 examples with you all together. The first one's going to be a super easy example. There's not a whole lot to it. So if I look at question number 2, I have y equals x squared. If I want to know what my a, b, and c are, it's always a good idea to go kind of on the sides and just say what they are. My a value is the number in front of x squared, that's a 1. My b value, this is almost like having a plus, this is like having a plus 0x and plus 0. So my b value is really that right there, so it's really 0, and my c is also 0. There's a very kind of minimal start to what we're doing here. It's in standard form, there's no other way to put it. The second one is find the axis of symmetry. So x equals the opposite of b over 2a. My b value is 0 over 2 times a, so 2 times 1 is 2. If you would go in your calculator, 0 divided by 2 gives you 0, so I know my x equals 0. Okay, so I know the axis of symmetry. The part that's going to cut my graph right in half is going to be right on the y-axis, right at 0 there. I also know that my vertex is going to be 0 something. Step 3 says to plug in this to find out what my y value should be. So if the equation is y equals x squared, I'm going to go where x is, and I'm going to put a 0. So y equals 0 squared, and 0 squared is 0. So the ordered pair for my vertex would be that owl-looking creature over there, so it'd be at 0, 0. Step 3 says to create a table and then graph. Okay, you could go into your calculator, and in your calculator you could go to y equals, and just go to second graph and look at your table that way if you'd like to. But you have to have some type of table listed here. We put that vertex right in the middle, 0, 0. Go to -1, -2, go to 1, 2. And if we plug those points in, 1 squared is 1, 2 squared is 4. -1 times -1 is 1, -2 times -2 is 4. Notice they do mirror each other. It's dead on perfect there. So I have a point at 1, 1. I have a point at -1, 1. I have a point at 2, where's 4 at? 2, 4, I think that's right. I can barely see it on here. And -2, 4. So when I graph it, I have a nice smooth line coming through that point. We know that it touches the x-axis right there at that 1 point, so it has one solution. So my solution, I'd say x equals 0 is my one solution. The directions also say list the domain and range. So if I say domain, that means how far does my graph go on forever and ever from left to right. This arrow tells me it's going to go to the left forever. This tells me it's going to the right forever. So for my domain, I would say from negative infinity is less than all the x values that are less than positive infinity. It's going to go forever to the left and forever to the right. For the range, so it's how far down does it go to how far up does it go. The farthest down that it goes is 0. So I'd say 0 is less than or equal to, because it's an actual point, all the y values that are less than. Again, the arrows tell us it goes up forever, positive infinity. We already listed the axis of symmetry. We said it was x equals 0, so we got that out of the way. And determine whether the graph has a maximum or minimum. This graph's going uphill, so it has a lowest point, so it has a minimum. All right, so we listed every single thing we need to know. All right, flip your page over. We're going to try another one. All right, I lied a little bit. I said flip it once, flip it twice. Go to question number 9. We'll just make this our second example, and then we can be done. That way you have a little bit of time to work on your own as well. All right, for question number 9. It's in order, x squared minus 8x plus 14. So in order, highest to lowest. Second step says find the axis of symmetry. So x equals the opposite of b over 2a. So I know that my a is 1, my b is negative 8, and my c is 14. So if I do negative b over 2a, x equals 8 over 2 times 1. 2 times 1 is 2, so 8 divided by 2 is 4. So I know that x equals 4. So my axis of symmetry is going to create that dotted line. Oops, that was ugly. It's going to create that dotted line right at 4. That's going to create the symmetrical graph for us. After I find the x, it says plug that x in to find the y within my vertex. So I'm going to go into my equation everywhere where there's an x, put it in parentheses, and I'm going to figure out what my y value should be. So I have 4 squared, which is 16. Negative 8 times 4 is minus 32 plus 14. You could probably use your calculator for this. I'm trying in my head. I hope I don't mess it up. So I get negative 16 plus 14, which tells me it's negative 2. So I know that my y value is negative 2. So I know that my vertex is 4, negative 2. So I'm going to go to 4, negative 2. I'm going to plot that point. Now I can automatically tell, I know in the directions I have to say whether this is a maximum or minimum. I can look at this and see that my a value is a positive 1. If it's a positive 1, that tells me right away that my graph's going to be going uphill. So this point should be a minimum. I do know that. If you want to wait till after you graph, you can do that as well. But you can if you want to. All right, second step. Now I'm going to erase that so I can make my table. For my table, I have x, I have y. I put my vertex right in the middle, 4, negative 2. I'll put 3, 2. You can even put a 1 if you want to. You can put more. Doesn't matter. 5, 6, and 7. Now for this one, I'm actually going to go into my calculator. So I'm going to grab one right now, make it a little easier on me. I'm going to go to y equals. I'm going to type in that entire equation. So x squared minus 8x plus 14. All right, I can look at the graph. I already see where it is. I can barely see it. All right, so I press second graph to look at my table. I fill in everything I want to know here. So go to 4. I see that at 3, it's negative 1. At 2, it is 2. And at 1, it's 7. Okay, so we got all of our stuff. We're going to go on. We can plot those points on our graph. So I go to 3, negative 1, 5, negative 1. I go to 6, 2. I go to 2, 2. I go to 1 7s off the graph. I don't need it in 7 7, so I didn't need those extra points. Graph my parabola. Put arrows on the top and bottom of it. That's it. I do need my domain and range. Domain, it goes forever and ever to the left and right. So I know it goes from negative infinity. Oh, that was bad. Whatever. Is less than all the x values that are less than positive infinity. For the range, the lowest value that we have is -2, and that's an actual point, so it's less than or equal to the y values that are less than positive infinity, because it goes on forever and ever. Then the only other thing we're missing the whole, like, major part of this, and that's the solutions. Okay, so if I look at this, there is no point that tells me exactly where it crosses on the x-axis. I can't tell on this one. Okay? So in this case, for tonight, what I'd like you to do, I'd like you to make it a little guess. I'd like you to look at it and say, all right, well, I think x would equal about 5.25 on this one. And I think on the left-hand side, it looks like about -3. Oh, wait a minute. That's not negative. What am I doing? It looks like about 2.6. I'm just making my little guess there. I'm taking a guess at where it actually crosses. Tomorrow when you come in, I'm going to show you on your calculator how we can use a button on the calculator to trace our graph and really figure out what the answer is, where it really crosses. Okay? All right, so we did a whole lot of talking there, did a little bit of practice. For tonight, I'd like you to go through and let's say homework is let's just say try from 5 to 14. So homework for tonight, let's do from 5 to 14 on there. Got it? You've already got one done. We did number 9. So that's it. All right. Good job. Have a great day. See you tomorrow, people. Peace.